All right, hello, and welcome to week 2. It looks like this is going to be the permanent room, apparently. You see the timetable yourself, they've just retained this room. There's a little detail that technically on Monday my intention was to have 2 lecture slots on the Monday, 1 on the Wednesday, so you get your 3 per week total. They've actually given us 3 lecture slots in this block. Generally my hope is that I won't use them all, because 3 in a row is a long session. So generally I'll just use 2 of them, and the third one will be there for overspill if we run late, or I can maybe use it as an ad hoc tutorial, or if someone wants to talk to me, because I don't have an office, so we can make the third one my office hours or whatever. But generally speaking, we'll try and get 2 and out, which would mean that we're generally going to be out of here at like 3 o'clock or something, if I've calculated that right. Okay, some other things that I'm going to kind of say almost for my own benefit. This room seems okay, but I do think the projector's quite low res, so I'm having to run the computer at a lower res than usual so that it looks okay on the projector. Last week I did 102 4x768. This week I've gone up a bit to 1200 by whatever, because I need a bit more screen real estate this week for showing text. Hopefully it'll be okay, but it's a little compromise I've had to make. Any other introductory remarks? No, I don't think so. And I did a test recording, so hopefully the audio is all right. The audio was slightly uncertain the first time I tested it, but I think we can continue. So today we start with the real programming work, and that's going to involve me giving you a bit of a crash course, if you don't already know it, in JavaScript. Anybody have opinions on JavaScript, one way or the other? Any JavaScript fans? Okay, at least one. Any JavaScript haters? Both. Couple. Yeah, we got fan and hater. That's probably the correct position. Yeah. Yeah, I think so. What are you doing?
You sure it's accurate?
Are you showing somebody a JavaScript quirk?
Yes.
Okay, I might get to that later if it's one of the famous ones, so just bear with me, don't spoil the surprises.
I've seen this one.
Okay, well, we'll maybe find out later. Yeah, so JavaScript's a kind of interesting choice of language, and there's definitely a question to be made about its general merits as a language and its appropriateness for doing game development, and I'm going to talk a bit about that, because it wasn't the easiest decision to make. So why are we doing JavaScript for a games programming course? Well, I did want to have a practical element in the course, so you could actually be writing stuff and getting your hands dirty doing real programming. But also, I didn't want it to be tedious, and I didn't want there to be a lot of overheads and complexity. I didn't want you to have to install complex IDEs. I didn't want you to have to deal with cross-platform problems. Some of you will have Mac, some of you will have Windows machines, Linux even maybe. And it all gets kind of complicated if you deal with all that stuff. Nevertheless, why JavaScript? I wanted to avoid complex IDEs, and I wanted to avoid languages like C++, where you have this kind of somewhat tedious cycle of having to edit the code, compile it, link it, debug it, watch it crash, go back around, do it over again. You'll get plenty of that in your other courses and in your life in general. Mm-hmm. But I thought it would be nice to kind of avoid some of that if I could. That's despite the fact that real professional game development of the type that I have done is mostly in C++, or in fact in C. A lot of game developers are actually wary of some of the object-oriented features of C++. So they use it technically, but in practice they're basically using the C subset of the language, and that's how a lot of pro game dev is done. You don't get too much of it done in JavaScript, but if you want to just get a kind of basic intro and cover the fundamentals, it turns out any language will do, really, and there are some things to be said in favour of JS. The other great thing about doing it in JavaScript is just that when you've created something, you can share it with people really easily, because it's just on the web. The web is the universal platform now. So the idea is that at the end of this course, when you've made your game, you'll have a URL that you can just point people at, your friends, family, and so on, and you just tell them, click this link and you can play my game, which is a lot less hassle than go to this website to download an executable and get your virus scanner to, accept that it's not malware, and then install it and download operating system add-ons and all this blooming DLLs that you need and all this horror that you have to do when you're doing real game dev. So that's another reason in favour of doing it this way. So it turns out JavaScript in a web browser has got certain convenience values that make it quite attractive. But as you maybe know, there are downsides as well, which I had to bear in mind as well. One of them is that classically JavaScript is considered to be a slow language, and that games are quite performance sensitive. You want to be running at 60 frames a second or whatever, and if you're doing a slow language, that you might not get good performance. Turns out that's changed over time. The JavaScript interpreters, compilers have got a lot more efficient, and the computers have got faster as well because of Moore's law. Right? So it turns out JavaScript is fast enough nowadays for doing the kind of games that we're going to be doing. So it turns out the speed isn't really a problem. Ugly, yeah, well, there are those who think JavaScript is an ugly language in various ways. And again, you can argue back and forth about that. My policy is that, yes, it has some warts, but it turns out if you're careful, you can basically avoid the ugly parts of JavaScript and just use a core of it that's fairly sensible. And if you do that, you sidestep the ugliness. And broken, well, okay. There are indeed things in JavaScript that might be considered misfeatures, things that are like really kind of stupid. Again, most of them are avoidable, so just avoid them is the policy. And it's a toy language for amateurs. This is what people used to say. A lot of game dev people are still very snobby about JavaScript, and they still think of it in those terms. I think, though, that the world has kind of moved on, and people have accepted that for all its ups and downs, that JavaScript is a sort of tolerable language. Either that, or they've just been beaten into submission by the fact that it's universal. It's like you can't avoid it now. Everything's on the web. So many apps are kind of web native now that it is just the primary language that probably most people have to use for most things. And it's not as terrible as all that, even though you can criticise it. The history of JavaScript is interesting. It was originally developed very quickly. The guy who created it, Brendan Eich, do you know how long it took him to write JavaScript? The whole language? He did it in, I think it was 14 days. And it shows sometimes, okay? He's a very clever guy, but he was doing it under very tight deadlines, and some of the weirdness about JavaScript is partly a consequence of it was developed in a huge hurry back in 1995, and they've been trying to fix the mess ever since. Okay. So I used to be a bit kind of snobby about JavaScript myself. I didn't like it, in part because the early implementations weren't very good. And also, in the early days, you couldn't do much with it. It turns out nowadays there are some extra features in HTML that make it more useful, but those didn't exist. So all you could really do with JavaScript early on was create annoying pop-up dialogues. That seemed to be its main purpose in life. And that led a lot of people to kind of hate the language for kind of the wrong reasons. In some ways, they were hating the ecosystem around the language. They were hating things about the web browser and not so much the language itself. So this has led to an argument that JavaScript is a kind of misunderstood language. And there's a guy called Douglas Crockford who's been quite a good force over the years for trying to persuade people that JavaScript is salvageable as a language. And he wrote a really good book called JavaScript, The Good Parts, which is how I learned the language eventually, that basically makes this case that if you ignore some of the quirks and the silliness, there's a decent language inside waiting to get out, and that was his whole policy. So he's written some articles about the language that you can look at when you get a chance. Talks a little bit about the background here. I won't tell you all of it, but this is basically his claim. He thinks that JavaScript is a nice, dynamic, object-oriented language, buried in all sorts of mistakes and historical accidents, including the name. The name's really weird, right? The name obviously suggests that JavaScript is related to Java. It turns out that relationship is actually very superficial. It's just the syntax, so it's got the same kind of curly brackets thing, and the for loops look the same, but there's more to a language than its syntax. Originally, it turns out, when Brendan Eich was designing JavaScript, he wanted it to be more like a classical scripting language. He wanted it to be like Scheme, which some of you might know. Maybe that would be even worse, right? But that's what he was going for, and in some ways, conceptually, it's more like a Scheme in that it's a dynamic language and it tries to be tries to have functions as first-class citizens and so on. But literally his boss told him, no, you need to make this language look like Java, because Java was the hot new thing back in 1995, and everyone was talking about it and saying that, oh, we need to rewrite all of our C code in Java, it'll be great, it'll be 10 times more productive and all this kind of thing. Turns out all it was 10 times slower. But at the time, Java was the hot thing, so he was explicitly told to make it look like Java, even though in a lot of ways internally it's different. So that causes some confusion. As Douglas says here, he says in a way it's in some ways, now you can debate this point, but he claims that it's got more of the heritage of a Lisp type language, which is what Scheme is, but wrapped up in curly braces syntax. And there are various other things about it that you can read about in your own time, I think. Okay. But the tide has turned, and despite its kind of ropey beginnings, JavaScript is now super popular. If you search for what's the most popular programming language, it does say JavaScript. There's various ways you can measure these things, but if you just look at, how prominent the web is, you can kind of see that already there's an argument that it's probably the most commonly used language. So here's an update they wrote, which is now very old, of course, about how JavaScript basically evolved. Again, I'll just let you have a look at that yourself if you get a chance. But the real thing that makes JavaScript worthwhile is simply it's the language inside the browser. Regardless of its individual merits, any language that was the one that allowed you to do things inside web pages was going to win, ultimately. There was even a period where it was maybe going to be Visual Basic. Like Microsoft tried really hard to make Visual Basic the language of the web browser. And luckily, by rushing it and putting JavaScript out, Brendan managed to kind of head them off at the pass there. So we got this other dodgy scripting language instead. And it's worth reminding you just what it is that the scripting language inside a web browser actually does. Because remember, the basic thing about the web, if you just think about pure HTML, people sometimes talk about HTML as a programming language, but it's not. It's just a markup language. It's just descriptive. It's just a way of taking a bunch of text and saying, this is a paragraph, this is a list. If you click on this, go somewhere else. Very trivial. And that indeed is what the web looked like in the early days. I have first-hand memories of this because the web was basically invented, I think technically in 1989, but you didn't start seeing it until into the 90s when the first web browsers that became popular started to appear. There was one called Mosaic that came out in, I think, 92 or 93. So I was at university from 90 to 93, and I remember late on in my time at university when we would, back then, people didn't have their own laptops and stuff. That didn't really exist. So you had to do the work in computer labs where they had Silicon Graphics workstations in them. And I remember going in there one day and there were rumours that there's this cool new program that you can play with called Mosaic, and it allows you to explore this thing called the World Wide Web that we'd started to hear about it, but it was kind of brand new. And it was rubbish, right? Because this is what it looked like. It looked like that. That's what the web's like if you don't have... what's all this rubbish? I don't care. That's what the web's like if you don't really have JavaScript or anything to enliven it. You just have the raw thing about it's blocks of text and some of the things you can click on and you take you somewhere and it's like, oh, great. And actually, that was quite cool because that was a step up from what we'd had before, which was having to type in FTP commands and using things called Gopher and all this kind of stuff. So this was much more pleasant. And if you were really lucky, you could maybe find out an implementation that had graphics on it. It would very slowly download a JPEG, take about 20 seconds. But this is what it was. And you probably know the history that the web was created at CERN in Geneva, the particle physics place. And when Tim Berners-Lee created it, his intention was it was a way of allowing teams that were doing research work to just share their papers with each other, or, kind of like little write-ups of things. Here's what I'm doing. Oh, and by the way, here's a link to some other thing that might be relevant. And you would just have this ability to connect documents to each other, just to sort of index them. That was really all it was doing. And that was it. This extends to some other things as well. Again, if you go back to like the late 90s when Google first appeared, just to show you how primitive things used to be. Do any of you know what the Wayback Machine is? Yeah, the Internet Archive, the Wayback Machine. So you can use that it stores archives of old websites that it snapshots It stores in a big database. And if you go back there, you can see what Google looked like the first time I saw it back in the 90s. It looked like this. And you would click on there to go to the prototype, where you would type things in and it would search its massive index to see if it recognised any of the words that you typed in. And that was so this was a comparatively fancy web page, because look, it's got a picture on it and everything. But it's not quite as all singing and all dancing as the things we've become used to nowadays. Another way, if you want to, without using the Wayback Machine, if you want to take a time capsule and go back 20 or 25 years and see what the web looked like, just look at any university academic, because they're still doing things the old ways. Do you know who Donald Knuth is? Yeah, some of you. He wrote a famous series of books called The Art of Computer Programming, which is where all your algorithms and data structure stuff comes from. You go and look at his website of this very moment. He's still alive and he's still trying to finish his fifth or sixth volume of this giant thing that he's been writing most of his life. And this is his super fancy web page. Again, it's just blocks of text, some of which you can click on. This is like one of the best computer scientists in the world, and this is his web page. And this is fancier than it used to be. He's had it brushed up. Again, he's had amazing innovations like a picture. Oh, look at this! Oh, wow! So these are the classic books that have got all your searching and sorting and data structures and all that stuff that you learn in your other classes. Yes, so the web, this is what it used to be until JavaScript came along. The point about JavaScript is that it's a programming language that's running in the background inside the web page. That means that the web page can change and adapt to what you're doing, so you can make them much more interactive. There was a time when it was called like dynamic HTML. The idea was that the JavaScript can see what your mouse is doing, and as you click on things, so it can simulate things like buttons and user interfaces, or it could let you, draw lines and things like this, none of which you can do in plain HTML. So the whole point is the scripting language gives you that kind of extra layer of programmatic control over things. And that's why today we have web pages that are much fancier and more shiny and interactive than the old rubbish that we used to have. There are many examples of this, and I'm sure you'll be familiar with them, but I thought I should include a couple just to prove the point. So here's a thing that is a web page, and no, it's not just a bunch of text with links on it. It's this super dynamic thing that's this actually works by scraping Wikipedia and pulling in all the articles and working out the dates that correspond to the articles to create this big timeline of history. And then it does all this fancy animation nonsense to let you see what's going on, and you scroll along down here. And all of this is stuff that HTML on its own can't do, but you can if you've got some scripting language running that's picking up on what I'm doing down here. Like I'm moving these cursor things, and it's letting me zoom in and click on things. And these videos may or may not work. The reliability can be a bit erratic at times. Yeah, it doesn't always get them right, but the principle of the thing's pretty cool. And this is just obviously just way more than vanilla HTML could do. Other examples, there's this guy called Neve, who's got a website full of little toys that he's made that show off various tricks you can do with JavaScript, playing games and stuff, the old-fashioned or something more elaborate like this thing where you can zoom in on weather maps of the planet. And again, you're used to this because you've seen Google Maps and stuff, right? But there was a time when that was super new and people didn't realise you could do that on the web, because you sort of couldn't without all this JavaScript-driven magic to make it dynamically load in all the pictures and figure out what to do. So you can see this terrible bit of bad weather they're having in America at the moment. And at some level, it's kind of amazing that we can do all this now. The web has become as much of a programming environment as like a native app, and it was not always that way, but it is now. So this is me desperately trying to persuade you that you can do things in the web with JavaScript, which you probably know already, but I wanted to make the case. This slideshow is another example. This whole thing that you're watching here is a bunch of JavaScript running in a web page hosted at the Slides site, which allows me to do all this little, paging through it as we go, and the little trick with the escape key where I can zoom out and navigate the whole grid of things and all. So this is all JavaScript magic. Lost my place. All right. So I've kind of explained to you what's going on here. What's happening is that the JavaScript code is running and it's manipulating the so-called the DOM, which is the representation of the HTML tree. And you muck about with that, respond to user events or the passage of time, and you can make cool stuff happen. So that's how it works. You take that, and you maybe take things like CSS as well for styling, although I don't really use CSS myself. And the end result is you can take the plain old crappy text stuff and you can make it look interesting. But what about games? Historically, the problem was you couldn't really do good games on the web, even with all this stuff. If you wanted to do games, you would sometimes use a third-party plugin like Flash, if you remember Flash. But Flash has been deprecated now because it had lots of problems. So using the native technologies, you couldn't really do good game stuff. You could do little bits and pieces, but if you tried to do a game, it'd be really clunky, wouldn't work very well at all, or you had to do these unreliable plugins. It was not a nice experience. There was even a time where people tried to do things with not JavaScript, but with Java. Anyone remember Java applets? No, they're probably too old now. There was a time when what they tried to do was embed Java programs inside web pages to try and let you do fancy things on the web, but that didn't work very well either. So for a long time, you couldn't really do good games on the web. But that changed eventually. In fact, should that be down here? Yeah, okay. I wonder if I'm missing something here. The point is that there's technology now that I will explain called HTML Canvas, which is the thing that eventually got added in HTML5 that allows you to create the kind of basic technology that you need to do viable games on the web. And that's what we're going to learn in this course. So as for JavaScript itself, you'll already be familiar with some of it just from what you learned about Java, or even if you learn C, because they've got similar baseline syntax. I think that in order to get to this course, you have to do the introductory Java thing or something like that, so you basically know this stuff. The syntax is braces and semicolons of the type that you'll be familiar with. And they're both object-oriented to a certain extent. But as I said earlier, it's not exactly like Java. The name similarity is a bit of a contrivance, but it makes it easy to learn the syntax, if nothing else. An interesting thing to know about the way JavaScript works is it's a reference-based language. So that means that if you've got a variable in the language, that variable you can think of as basically it's a pointer that refers to the real object. That's different from C. C and C++ are value-based languages. So in those languages, if you've got a variable, you should think of that variable as more like a box that actually contains something. So if you've got like a variable x equals 10 in C, think of a memory location called x. It's got a 10 in it. And if you do y equals x, what you're doing is you're copying the contents of the x box and putting it into the y box. So now you've got two boxes, and they both contain their own copy of the number 10, right? But JavaScript, like Java, is reference-based. So what actually happens in the JavaScript equivalent is your variable x, you should think of as more like a label that points to something. And it points to the number 10, which has been stored somewhere in the language. And if now you say y equals x, what you're doing is you're saying, I want a new label labeled y that also points to the same thing that x does. So you've got one thing with two variables referring to it. And this is important because it means that when you do things like mucking about with variables and changing their value, you have to be careful as to what it means, because if you change a thing that's got multiple variables pointing at it, they all see the change. And that's what makes a reference-based language. It's part of the character of it. The other thing about JavaScript, like Java, it's garbage collected. So you don't have to explicitly do your own memory management. In C, of course, you do. In C, you allocate memory to make things, and then when you don't need them anymore, you have to tell the operating system you're finished with them so that it can reclaim the memory, and if you don't, eventually you'll run out. But Java and JavaScript have got garbage collectors, so they know how many variables are pointing to a certain thing that you've allocated, and when that number goes down to 0, it knows that nobody can refer to this anymore, and it can clean them up behind the scenes. And garbage collection is seen as one of these convenience things that makes writing programs much easier, although it sometimes has performance penalties because the garbage collector has to run in the background and do work. So this is just a not very meaningful example, just some random code that I copied in here to show you what JavaScript functions look like. So the keyword function is what's used to describe a function in JavaScript, and the rest of it is just like it would be in Java. You get the name and the parameters in parentheses, curly brackets. You got if statements, dots to refer to things inside objects. The for loop is exactly the same structure. It's the for with the three. Oh, that's actually look, there's like a comma in there. So that's one clause. So that's the first clause and a semicolon, and the second clause and a semicolon, and the third clause. And this is all stuff you should be able to understand. Plus equal operator, for adding a thing to itself. Just all kind of fairly standard stuff. Other parts of the syntax, again, they're basically just what you would see in C++ and Java. You've got, the AND operator, the OR operator, exclamation mark means not, all these things that you hopefully already know. Okay, so we're going to dive into it and do a little bit of programming today, simple stuff. So I'm going to attempt to do this interactively, using the developer tools that are built into the modern browser so you can see it while it's running. One thing that I'll tell you is, in this course we'll be using JavaScript in something called strict mode. This is something where they tried to fix some deficiencies in the language. The original spec for JavaScript is too permissive. It lets you do. You don't really need your laptops for this, by the way. I'm going to show it to you, so you don't need to bother. You can join in if you like, but you don't have to. The original JavaScript had various deficiencies. It was tolerant of things in a way that would invite error. So they added a thing where you can now have strict mode, where you just say use strict at the top of your program, and that tells it to use a slightly different set of rules for things that are safer. When you're doing stuff in the console, as I'm just about to, you don't have strict mode, so it lets you do some things that are considered slightly bad form now. I'm just mentioning this for completeness. That when we're writing real code, we'll do it all in strict mode. The console is almost like that, but it's just slightly different in a few ways that we'll take advantage of. The other thing we'll take advantage of is JavaScript will basically, if you want to keep life simple, you should treat JavaScript as being like Java and C, and that it's a language where you put semicolons at the end of your statements to separate them from each other. Now, it turns out, because JavaScript was originally intended for amateurs, and the whole semicolon thing, confuses people, JavaScript tries to basically guess where the semicolons should be if you forget to put them in, right? So in the early days, people would write JavaScript without the semicolons. They would just write statements, and the parser for the language would kind of say, that doesn't make any sense. Would it make sense if I put a semicolon in there? Oh, yes, it would. That must be what you meant. Basically, a kind of terrible idea to try and make the language easy to use, with the downside that sometimes, of course, it would put the semicolon in the wrong place and cause peculiar behaviour. Again, when we write real code, we will not use that miss feature. We'll put the semicolons in. But when you're working in the console, sometimes it's convenient that actually you don't need to put the semicolons at the end, and that it'll just figure it out itself. So that's another thing that we take advantage of a little bit. Right. Okay, so let's get the console up. To do this, I'm going to slightly refer to this thing over here. Hold on a sec. Right. So when you want to use the console, how many of you already know how to use the developer console in the browser? Well, a fair number. I guess you do this in you'll take a web programming course. You've just figured it out. Maybe I don't need to dwell on it then. So it's fairly easy. It's what is it? Control-Shift-I or something brings it up classically. So it's just an option that's hidden away inside, developer options. By default, it appears as a sidebar nowadays, but you can detach it. There's a thing up here where you can, somewhere in there, is it? Yeah, for the docking mode. So I've just detached it so it's its own window, and I've zoomed it up a bit so that you can see what I'm doing, and I've used Control+ to make the font a little bit larger, just so it reads okay. But this is it. I'm just inside the console for an empty web page that I created. So let's just type some stuff in. So if I just do hello, it says hello back to me, so that's nice. And if I do hello plus, do it that way, Now, this already, I'm guessing those of you with a bit of programming experience, you can kind of intuit what's going on here. But I'll point out just straight away, this is slightly strange because plus is a mathematical operation that applies to numbers, and you'll know that some languages will not let you try and add strings together because that doesn't make sense, right? Because adding is for numbers, maybe, depends how you define it. But JavaScript is permissive, and it kind of says, well, if it did make sense to add strings, what would the interpretation be? What would it mean to add two strings together? Concatenate them, right? So it does that. So you can't add strings in JavaScript, and it just says, okay, just chain them together to make a bigger string. That's what add means, which is okay until you start to think about the symmetry, and you say, well, what does it mean to subtract strings? And that doesn't work at all.
Have you tried string 10 minus 1?
Yeah, I've done these things. I know where you're going. Let me get there more in time. But yes, it's lots of fun. Okay, so that's just a basic kind of simple string add that you can do. I will just point out that this is allowed to just ad hoc create a little, simple string printing routine. We didn't have to declare a big function. We didn't have to say public class hello world, public static void main string arg system.out.println hello world, or any of that rubbish. You just type it in and it works. There's something to be said for this, that a certain type of language, it just tries to be easy to use based on an interpreter where you just type things in and they work. There's obviously practical convenience to that compared to the more heavyweight approach of having to create a whole bunch of boilerplate and then run it through a compiler and do all that stuff. Obviously, there's a reason why we have both approaches. The compiler thing tends to be more efficient in the long run, but this is nice and easy and gets things done. Okay, so that's just a bit basic string thing. Let's do some things with numbers. You've already seen a number up here, but I'll just type in another one. 1, 2, 3, 4, type in a number. And just in the same way that when you do hello, it echoes it. You do a number, it echoes it. Just prints the result back out. And because this is an amazing, fancy, super modern 21st century computer, you can also get it to do arithmetic. So there you go, a triumph. It can even do hard arithmetic, like division. And as I'm sure you know, division is represented by a slash in most programming languages these days. So you can do 12 divided by 4. Hooray! What about if I did 12 divided by 5? Do we have any takers as to what the answer is for that? There aren't too many options. Just give a guess. What do you think?
2.4.
I think it's going to be 2.4. Anyone think it will be 2 because you're dividing two integers? So wouldn't it just divide them and keep them as integers? Yeah. It is indeed 2.4. Now, if you're doing this in, well, C is the one I think of, but I guess Java as well. In those languages, if you've got two typed integers and you do a divide on them, it produces an integer result. So it does the truncation. Certainly in C it does. But not in JavaScript. That's actually, again, JavaScript is trying to do what an ordinary, normal person who hasn't had their brain damaged by being taught an introductory C course would expect. And probably the first time you saw it, you would think, well, 12 divided by 5 is 2.4. That is obviously the correct answer. But computers sometimes don't like to do that because they use the typing thing. JavaScript does what you would have thought was the normal thing, even though if you have a bit of programming training, it maybe looks a little bit strange because it's done a type variation. The secret of what's going on here is there is no type variation. JavaScript doesn't have integers. Not really. Everything in JavaScript is actually a double precision floating point. So it's all floating point math that's actually happening, at least technically speaking. Sometimes it cheats, but that's sort of technically true. So with that in mind, what's going to happen if I do 10 divided by 3? What's the answer to that? 3.33 repeating. And people agree? Yes, is that what you expect? And how long will it repeat? How many 3s do you think I'll get?
Well, it does a double point precision, so 3.33. That's 3.4. So 3.34.
You think it'll round it to 4?
Yeah.
The 333 doesn't round to 4. But it might. Yeah. Oh, well, okay. Any other suggestions? Any guesses what it's going to be? We think it's 3.33, a couple of digits, and then maybe a 3 or maybe a 4. We don't know. Okay, it's that.
Oh.
So first of all, more digits than you might expect because double precision is actually, remember it's not single precision floating point. Single precision floating point, you're maybe looking at sort of 6 digits or something. Double, it's going to be more than that. And slightly weirdly, it has in fact done a weird rounding thing at the end. It hasn't even gone for 4, it's jumped right up to 5, right? Which just seems not right at all. but there are reasons for this. And they're not JavaScript specific. Some people see things like this and they think, that's JavaScript being strange. No, if you do this in any language that has double precision floating point and you make it print it out with the right number of precision digits, you actually get the same answer. This is the way floating point math works, which a lot of people don't fully understand. Another illustration of that is, and I mean I've kind of given it away a little bit, but what is 0.1 plus 0.2? I'll go on, just say it. Be an idiot, say it. 0.3, of course it is, right? That would be perfectly sensible. Of course it is. No, it's not. It's 0.3 plus a lot of zeros and a 4 for no goddamn reason. And this, to this day, I think if I switch back to the other window, yeah, that's my little dig at Java there. This piece of arithmetic here is not a bug. People think it's a bug, and to this day, I think it's actually sometimes the most common bug report in JavaScript is people who encounter a version of this at some point. They're doing some maths and they realise it gets the wrong number, and it's been here close 23 years ago. But people still add to it. I think you go to the bottom, you're bound to get somebody who just updated this recently. Okay, 2 years. Maybe they've done a dupe, but you get a whole ridiculous amount of stuff here with people trying to point out all the ways in which JavaScript is terrible because it can't even do basic arithmetic correctly. It's not JavaScript's fault. As I say, if you do this in C or Java and you make sure it prints the thing out to the full number of digits, the trick is that those languages sometimes don't print it all the way to the end so you don't see it. They hide the dodgy digit at the end. But the dodgy digit is actually part of how floating point math behaves in computers. And have you been taught how floating point math actually works? You know the representation of it. Got one person nodding. You're a bit further on than the other students. So I think most of you haven't encountered it yet, and a lot of people seem to not know this. I've met like professional programmers who don't really understand how floating point math works. And I think I should tell you a little bit about it because it's worth knowing. Otherwise, you'll always think of floating point as being magic. You know, it's like this strange, crazy black box that does random stuff, and you'll never really understand. So I'll give you just like the basics of it.
Yeah, okay.
So one way to show it will be to show you what floating point looks like for real, and the other way would be to do double precision floating point. Don't talk, please. It's actually very distracting. I can hear it and it throws me off, so try not to do that. So here's the wiki article that you can maybe look at about how double precision works. But basically, this is the core of it down here. The way floating point numbers are stored in computers is it's the computer equivalent of scientific notation. So when you're dealing with big numbers in science, like 6.75 billion or something like that, you call that 6.75 times 10 to the 9. You always kind of reduce it to, usually it's the one digit point something times 10 to the power something, right? Well, the binary equivalent of that would be some binary number that begins with a 1 point times 2 to the power something. It's just the exact binary analog. And that's how it's done. So the way it's actually stored internally is it's for double precision, they've got 64 bits, and 1 bit is the sign. This bit here is the exponent, so that's the 2 to the power part. So you can have 2 to the power, and this is kind of the 10 or 11 bits in here. So you can get 2 to the power 1024, I think is the sort of the top end. And then a bit down here that's the kind of the fractional part of the ones and zeros. So you know that when you do decimal arithmetic, some things are fine. Like if you've got like a quarter, it's 0.25, and that's fine, and it's a precise answer. But if you've got a third, it's, as we saw, 0.3 recurring, right? And that's just because it's just the nature of decimal that even though a third is a perfectly sensible, rational number, you can't represent it as tenths and hundreds and thousands in a finite way. It just goes on forever. Well, it turns out binary's got the same problem. There are some fractions which they don't represent cleanly in binary, and unfortunately, 0.1 is one of them, right? So although 0.1 looks like a simple finite, a finite expression to us, inside the computer, it turns out that's a bit like 0.333. It's a fraction that goes on forever. So, and because computers don't have infinite memory, it's only got 64 bits to store it in. It ends up having to truncate it at the end, so you lose a bit of the number. And that's why when you type in 0.1 into the computer, what it actually stores is not exactly correct. And that means that when you do arithmetic with it, eventually you kind of get cumulative rounding errors. And that's why sometimes floating point math ends up looking strange. You can kind of see a bit of this here. If I took something kind of simple like the number 3. So the number 3 is 1, 1 in binary, right? It's fairly simple. And so you'd sort of expect the representation to somehow have like have 1, 1 in it somewhere. And it nearly does. There's a caveat though, that the leading 1 is implied, so it doesn't get stored. So you only end up needing the second one. The first one's kind of invisible. So if you take 3 and you convert it to binary, it actually ends up being this. This is the second of the 2 1s in the binary representation of 3. This one over here is to do with the exponent part, which you don't have to worry about. So you get that. So 3 had like 1 bit set there. And if you did 3.5, you're adding a half, which in binary is like, a 1 after the binary point. So you end up getting 2 dots there. And this is kind of how it works. And for some things it's fine, but there are other things like 0.1 where it doesn't play very nicely. And it turns out you do that in binary, it's a repeating fraction like this, which would go on forever, except that it decides to round it up at the end. So you get this slightly distorted thing where you can see that what you typed in as 0.1 is actually stored internally as a slightly different thing. And you have a similar story with 0.2. It turns out it doesn't get stored exactly right because it can't. Again, it's just an internal rounding error. And you do arithmetic on these things, and sometimes the result that pops out, the error is big enough that you can see it, and that's why you get the weird answer. So that's what's going on there. And much as people like to mock JavaScript for this, it's not really a JavaScript issue at all. Right. Okay, hold on a sec. Wake up, computer. Oh, excuse me. All right, a bit more maths, seeing as we've got started on it. So there are other things you can do with maths. You can do the mod operator that you probably know from other languages. 17 mod 5, what's that going to be? 2. 2, right. So it's the remainder after the division, that's what it means. And yes, it does the right thing. But remember I said that remainder after a division is a concept related to doing integer arithmetic, isn't it? It's what's left over when you do whole number divisions. But there aren't really whole numbers in JavaScript. So it means you can do perverse things, like saying what is 17.1 mod 4.9. And what's that going to be? Well, it's sort of the same thing. It's what would be left over once you had done a pseudo-integer division. So the integer part of this is about 3, and then the leftovers are going to be about that. And again, with another little kick at the bottom, because, hey, floating point, great. So that's what happens if you do that with non-integer inputs. There are libraries in Java. Well, libraries, I say that. There are certain special objects that contain constants that might be useful to you. One of those is called math. So the thing called math that you can get, and it contains all sorts of numbers that might turn out to be useful to you, and functions as well. But the one I'm going to look at just now is good old pi. What's that going to be? Anybody? 3.14, 159, 265, 358, 979, 32, 38, 46, 26, 43, 38, 32, 79 approximately. Yeah. JavaScript actually doesn't know it as well as I do. I happen to know it to 30 decimal places because I'm a dork. But that's the closest as you get, which is near enough. Right. And there are other things in the math library that are going to be useful to you. There's a thing called pow, a power function. It allows you to take one number and raise it to the power of another number. So what's that?
256.
Anybody think anyone agree, 256? Yeah. Yeah, it is. And you can do it the other way around, just for completeness, in case you didn't know which one came first. You did 8 to the 2. What's that?
Missing the dot tower.
Oh, yeah, well done. That was not a deliberate mistake, but well spotted. Right, so what's power of 8 to? Yeah. Okay, just obvious. That's not a trick, that one. I'm just telling you how it works. It's got trig functions in it as well, which is useful. So you've got like sine and cosine. So remember how when you try to mentally visualize how sine and cosine work, imagine you've got your unit circle, it starts that way. Try to face you here. Starts that way, and then as the angle increases, you get the kind of, if your angle was at 45, you're up here, and cos projects it down onto the x-axis, and sine projects it across to the y-axis, right? That's why when you're doing like trig stuff, it's always, your xy coordinates tend to be cos angle, comma, sine angle, right? That's how it works, right? So you take sine, remember that sine is the projection onto the y-axis, yeah? So if I say sine of 0, what's that going to be? Somebody thinks 1? Remember, the angle is 0, and you're kind of projecting the line onto the y-axis, so it would be 0. Okay? And as the angle goes up, you'd be projecting it, once it reaches the apex, it would be matching onto the full y-axis. So if you go right up to the apex and you say, what's sine of 90? What's that? 1. How many thinks 1? Yeah, most of you. Yeah, well, you're wrong. Another bug in JavaScript. It can't even do sine properly. What's happened? What has JavaScript done wrong?
You're doing it. It's in radians.
Mm-hmm. The answer, in case you didn't hear it, these functions work in radians. Okay, and that's true in most programming languages, and it annoys people, but it's actually the right choice. Mathematically speaking, radians make a lot of sense. That's why you use them in calculus. For example, the derivative of sine is cos, only if you're doing it in radians, right? That's why radians are the right answer. If you do it in degrees, you have to multiply out the result by a constant. So it turns out degrees are the wrong thing. I mean, I say wrong, just historically, dividing the circle into 360, there's no mathematically robust reason for that. There's a practical reason for it. Do you know what the practical reason is? Why we have 360 degrees in a circle and not like 100 in a decimal world or some other number? The base 12 system from Babylon, you say?
Or assume that it's like that.
Yes, you're right. You say 12. I have to say 60 though. To me, it's a 60, but 12 and 60 are both important numbers here. The ancient Babylonians really liked the numbers 12 and 60, particularly 60. That's why we've got 60 seconds in a minute, 60 minutes an hour. We have residue from these. And basically, the thing about 60 is just it's very divisible. You can divide it by 2, 3, 4, 5, 6, not 7, but quite a lot of things. So it just turns out when you're trying to slice things up into regular units, it's quite a good number to use as your basic number. And we have residues of that in our culture, and one of those is the 360 degrees. But radians turn out to be the sort of mathematically more sensible way of dealing with angles, and most programming libraries, the trig functions are indeed based on that. So the way to say 90 degrees in radians, what is that? What would that be in radians?
Pi over 2.
Pi over 2, that's right. Because you get 2 pi radians is one whole circle, pi radians is a semicircle, pi over 2 is a quarter circle. Okay, so, and you can do that with the thing. It's got pi in it, of course, so we can say pi over 2, and that's us got a quarter circle. So now we have got what we think of as 90 degrees, and if you do the sign of that, it is indeed 1. So another alleged bug in JavaScript that turns out to be a bug in your brain. All right, that's some numbers. Let's talk about variables. So we started off by typing in hello, and we did it in quotes, which meant that it was a string, like that, right? But if I do it without the string, then it's a variable name, okay? Except we don't have a variable hello defined yet, so I've referred to a variable that I didn't declare. So it catches that and it says, you don't know what you're talking about. So that's what's going on there. If I want to declare the variable, there are a couple of ways of doing this, but the classical one in JavaScript is you put the word var on the front of it. You can also use let nowadays, but var's the older one. So if I say var hello, what I'm doing is I'm saying, I want you to actually make a new label in your system that's called hello. I'm declaring the name, right? Now, that in itself is just a declaration, so it doesn't produce a useful value, which is why it says undefined here. But it means that hello now exists. And if I type hello in, you'll get the value. Now, it turns out we created hello, but we didn't assign it to anything, so the value of hello itself is also undefined, which we're now going to fix. So take hello and just assign it to something. So remember, hello is like a little label in memory that currently wasn't pointing to anything at all. I'm going to make it point to the string greetings. and the assignment itself echoes its own result. But if I were now to say, just ask it what is hello, it would say greetings. Okay, so that's unsurprising, I think. Now if I take a new thing called greet, and I say greet equals hello, any guesses as to what happens here?
You didn't say variable, so greet undefined.
Correct. Well, nearly right. So the comment there was that I didn't put var on the front of this, so greet's an undefined variable. It turns out if you do it in the console, it guesses it for you and it implicitly creates it. So it will actually create a var called greet just in the console. It wouldn't do that in real code. That's just a quirk of the console. So this is going to work actually, and it creates a new variable called greet that points to the same thing as hello did. So there's one string in memory called greetings, and there are two labels that both refer to it. That's what's going on. Okay, so if I now do this, which one shall I use? I'll use double equals because you've seen double equals before, right? So double equals is the comparison thing, obviously, not the assignment. So I'm saying, are these two things the same? Are they the same? Yes, they are. But I'm going to tell you right now, try not to use double equals in JavaScript. It's broken. It works for certain obvious cases, but when it gets non-obvious...
Double equals refers to the memory. It's the same memory location.
No, it actually doesn't. It's more complicated. I'm going to explain in more detail. I think maybe it might be Wednesday before I explain it. The actual behavior of double equals in JavaScript is very strange. It's basically a bad decision that was made in 1995 that causes all sorts of problems. And the way they fixed it was they couldn't change it because once you've made a mistake in a language that's out there and used all over the place, you can't change it because if you change it, you're going to break things. So the way they fixed the equals operator was say, forget that old rubbish one. We've got a new one. It's even better now. That's 3 equalses, and this is the one that actually works, right? So in all your own code, use the triple equals because double equals will come. It works most of the time, and it bites you in the arse, and it fails in surprising ways. You should actually use triple equals in JavaScript. Okay, let's go back to, so we had our string hello and it had its value. I'm now going to assign it to something that means the same but is technically different. Okay, so hello is now hi. What is greet? Who thinks it's going to be hi? Couple, who thinks it's going to be something else? Greetings maybe. I think maybe more people think it's going to be greetings. So it turns out, and this is a little bit of a head scratcher, that greetings is the correct one. Because although these variables can share references to each other, like when the string greetings had hello and greet both pointed to greetings, right? When you did hello equals hi, you didn't change this one though. You created a new one and you said hello is now a new string over here called hi. So the other one still points to the old string. Now, if this had been an object and you had mutated the object, then both variables would have seen the effect. But when you do a string assignment, you're actually creating a new string, and one of the variables is made to point to the new guy because strings are immutable in JavaScript. Once you've created a string, it won't change again. It gets shared by all these other things, you see, so you don't want it changing. And if you create a new string, you've basically just attached a label to a new entity in memory. And that can often be confusing, but that's the way it behaves. And we can now see that this is sort of the case. If I compare greet and hello, they are no longer the same. Okay. If I want to see if they're the opposite of the same, the not equal to in JavaScript is a bit like the not equal to in your standard languages, except it has to be 3 long because to be the new version, right? So that's the correct not equal to in JavaScript. And they're just the opposite of each other. Now what's going to happen? So we've got hello, which is a string, and we've had various values in it. I'm going to assign it to 99, right? But 99 is not a string, so what's going to happen here? Is this an error?
No.
It's not. Okay, oh, you're ahead of me. Yeah, you can do it. So now hello is a number. It used to be a string, and now it's a number. Again, so one of the things I've mentioned about JavaScript is it's reference-based rather than value-based. The other thing is that it's dynamically typed. So that means that the variable itself doesn't really have a type. The variable is just a label, right? And that label can point to a number or a string or an object or an array. So the variable doesn't have a type. the things that it points to have types, but the variable doesn't. So you can do things like this. Whereas in a statically typed language like C or indeed Java, you've declared that variable as being, let's say, an integer, then you can't assign it to something that's not an integer anymore because the box isn't the right size. Was one way of thinking about it. There's a kind of integer-sized space somewhere that needs to have integer things in it. But JavaScript doesn't work that way. A number of modern languages are dynamically typed. Python is as well. Dynamic typing seems to have become more popular in recent years. A lot of new languages seem to lean that way, but you still have both. Some are static, some are dynamic. It's just one of these choices about language design. So we can now inspect the type of a thing. There's an operator called typeof in the language. So I can say, what is the type of hello? And it will tell me. Now it's worth noticing that what has it actually returned? What did type of hello return?
A string.
It returned a string, right? A string that says number, right? But that's a string, which has consequences. One of the consequences is, what's type of hello?
String.
The string. I mean, it's totally correct, but it's slightly puzzling. You just have to remember, type of expresses the type as a string, and that's just the way it is. Get used to it. Okay.
You can also do type of not a number.
Oh, now, yes, I'm going to get into that as well. You seem to know all the quirks. There are some crazy ones that I'll get to later, but I don't want to fry too many brains simultaneously.
It's been a learning experience.
Mm-hmm. Yeah, these quirks are something I'll come to more on Wednesday, I think. There's definitely some odd things about JavaScript that you have to remember that can lead you into error. Having said that, we're still we're kind of halfway through here, but it is about the break time. So I'll pause here and we'll start up again. Let's say in just about 5 minutes or something. But if you want to go and have a little walkabout or need to go to the loo, now's the time to do it.